Welcome to the Biped podcast, where we elaborate on urban clean energy transition and how to improve related concepts, processes, and technologies to facilitate transformation toward climate neutral cities. My name is Pavel Kogut, and in today's episode, we will focus on modeling positive energy districts with cross-sectoral data. We will explore this in the context of local digital twins. The technology provides a digital representation of urban environments that local stakeholders, from expert planners to the general public, can use to improve the way in which cities are planned, in which cities are built and operated. Now, traditionally, local digital twins create virtual replicas of a functional territory by combining static and real-time data with dynamic models of things like energy, traffic, buildings, and natural environment. However, focusing narrowly on these domains means that digital twins of positive energy districts will lack representation of other important elements that make up the urban fabric. Local digital twins that omit social properties will only provide a partial representation of an area they are designed to mirror. Now, how can we develop more holistic digital twins to create better positive energy districts? That's the question we'll be exploring today with Martin Traunmueller. Now, as an architect and computer scientist, Martin is an expert in urban computing and urban data science, both professionally and academically. He worked as an architect in Dubai and Vienna before continuing his academic career at University College London and the Center for Urban Science and Progress at New York University. Martin is currently utilizing his knowledge of urban technologies at the Austrian Institute of Technology, where he works as an urban researcher, bridging the gap between research and application. Hello, Martin. How are you? How are you doing?
Yes, hi. Hello, and a very good morning, Pavel, and to all of you out there. Thanks for the very warm welcome. I'm doing pretty well. As we just have noticed, the weather is now getting better here in Vienna. So yeah, everything good here. Thank you.
Nice to have you on the podcast. Martin, I mentioned the word soft data, which is an interesting term, and I'm not sure if I myself am very familiar with it, and maybe others who hear the term for the first time, they're not familiar with it either. So can you explain us what soft data is and how can we use soft data to represent social dimension?
Mm-hmm. Yeah, sure. Talking about soft data, so as the term already says, is like data that is rather, let's say, less tangible than hard data. Yeah. Compared to soft data, hard data is the data what I think most of us understand with data that can be collected on a very large scale, let's say through sensors or through different counts and so on and so forth. And they can be measured into numbers very, very easily. Yeah. So as an example, you can say the amount of crime that is happening within a city and so on. So crime counts, or sensor data that is measuring the air quality within a building, or different kinds of traffic counts and so on and so forth. So those are discrete numbers that can be measured on a quantitative scale very, very easily. Yeah? Now you have on the other side soft data, which describes properties that are, let's say, less tangible in terms of the numbers. Yeah? So when we think about emotions that somebody has now, especially in the urban context, when somebody is going through a city and so on and so forth, emotions, perceptions, and so on and so forth. Yeah. So those are properties that are usually collected in a qualitative scale, in a following qualitative methods, as for example, handing out a questionnaire or doing or conducting an interview, which on one hand side gives you very rich and very deep insights into those properties, but at the same time, the sample size is then very, very small. Yeah. So those are, if we want to differentiate between the two of them, those would be the main points. Yeah, so one is collected on a quantitative scale, one is collected more on a qualitative scale. Yeah. Now if we see that also specifically now when we see about to the topic that we cover with biped related to energy consumption, you could assume that soft properties would be related to the climate perception indoors and outdoors. For example, how is temperature indoors perceived by people? And is this also properly reflected by the settings of, let's say, an AC or of the heating properly? Yeah.
Okay, that's interesting, Martin. So it looks like it's located at some very granular level. And I was wondering if there are any challenges with acquiring this type of data, and maybe you have some experience when you needed to obtain soft data, but you found it difficult, and how did you overcome this barrier then? If you can give us some examples of that, Martin.
Yeah, sure. Yeah, personally, I was very much involved, also especially throughout my PhD, in asking the question, okay, how can we now come up with methods that are putting the collection of soft data on a quantitative scale? Yeah. Like as I said before, it is really hard to collect this on a larger scale. But some methods have been developed, also connected with the rise of modern technologies. As for example, I was involved in one project where we used a mobile phone app, or we developed a mobile phone app that the user could put on the mobile phone, and the app asked the user throughout the day on random times and, at random geo locations where, of course, the person just has been at this very, very time. For example, like how happy he is, or how he feels. Yeah. And then you can basically give feedback via the mobile app, via a Likert scale, and say, okay, you feel so and so bad, or so and so good, and so on and so forth. Right. So the questions you basically can then choose that you wanted to ask, but the output was that a large amount of crowdsourced data, crowdsourced emotions, crowdsourced perceptions has been collected. And this, of course, in relation to a specific geopoint and to a specific time. Yeah. And of course, you can then extend this. You can set up a user profile, and then you can relate the votings, of course, also to specific people. Okay, so this was one method where we used a mobile phone app. There is one other method where we said, okay, mobile phone app, and I have to mention also this whole thing happened like about 15 years ago. So smartphones were already out there. Many people already had smartphones, but of course, especially in those days, yeah, you keep out a large number of people. Yeah, when we think about the older people, when we think about the less wealthy people and so on that could not afford a smartphone, hence they could not get the app. So you basically focus on a very, let's say, very, very defined profile of people, yeah, that you collect and the votes from. So the question was, okay, how can we scale this up, and how can we include also those people? So we came up with the idea to make a web page where we can crowdsource perceptions. In this case, it was crowdsource perceptions of safety and also of perceptions of the urban environment based on Google Street View pictures. Yeah, so you can imagine a web page where we showed Google Street View pictures, and we asked people how safe they would feel there and how wealthy they think that the neighborhood is. Yeah, and they could indicate this with a Likert scale there. Of course, knowing the limitations, and of course also coming from the architectural background, it is a different thing when you sit at home in front of a screen, when you have to perceive a urban place. Yeah, it is different from that when you are in situ and you experience the whole thing there. But those are all limitations that we also considered there. Yeah? So we were then able to collect a very large amount of votings that we were then able to connect to different kinds of pictures and especially to the properties of the pictures that you would found there. Properties as, for example, the colors that you find there. Like, what is the amount of, I don't know, green there, yeah? Or what was the other thing, scale, yeah? Like, how big are the buildings and so on that you see there? Or, for example, in terms of how closed walls are there many windows? Are there many gaps and so on and so forth? Yeah, so there were a couple of properties that we defined, which were found in the picture. And then based on that, also with the votings, we were then able to train an image recognition algorithm that basically allowed us to take the Google Street View pics for a whole city, and we scanned them through, and you basically come up with a map that shows you the perception of people, how safe they feel or how wealthy they thought that the neighborhood is there. Yeah? So you can imagine this visualized with many, many dots on a map of a city, each standing for one Google Street View pic and visualized from a scale from red to green, yeah, how safe they feel. Yeah, that was one way to basically use to use tech in order to scale up a qualitative study on a quantitative scale. Yeah.
Okay, so speaking of cities, if we take Aarhus, for example, and we're looking to create a positive energy district for a city like Aarhus, in your opinion, what would be the value of adding social dimension to cross-sectoral modeling? And how can socioeconomic data be combined with other domains like energy or mobility to support decision making?
Mm-hmm. Mm-hmm. Very, very good point here. Yeah, also specifically now coming from the urban, side, I always stand for this, that to understand a city and how a city works. In our case, of course, also how the energy performance, works out for a city or for a neighborhood. You need to see a city as a whole. So you need to have a holistic view on the city, which includes many, many, many properties, because a city is a very complex, thing. It is way, way more than just the energy topics, just the mobility topics, which are, as we say in Biped, so often the usual suspects. It is way more about this. Yeah? It is about the people. Yeah, talking about the social landscape of a city. It is about the built environment. Yeah, like for example, about the different kinds of land. The land uses there. It is about how buildings, about the heights of buildings and so on and so forth. In terms of the social dimensions, what I just mentioned before, those could be, for example, different kinds of demographic properties of people, like, for example, age, gender, where people come from, all of those kinds of things, the educational backgrounds and so on. And then, of course, you also have the economic landscape, like how a city performs. So those are all properties that basically support to give an holistic view on the whole topic. Yeah. And in this case, I also want to refer to a book which is called Space and Place, which came out in the late 70s. I think we can also put the reference there maybe down there in the show notes. Space and Place by Tuan, where he differentiates between space, which is basically just, urban place without people there, and then place, which is basically to include the people there and how they basically change the whole place. Yeah. To change the whole perception of a certain place. Yeah. So you have always to add those kinds of properties in order to come to a holistic view. Specifically also when we talk about the energy consumption. Yeah. For example, the energy consumption could be high depending on the social and economic backgrounds, and of course also the educational background. As for instance, what we also found when we went through the literature, more wealth of the people creates a higher energy consumption. Yeah, when you think about cars, yeah, like people own, let's say, 1 car or 2 cars or 3, and so on and so forth. Also, the number of electric appliances what people have. People have an AC and so on and so forth. Yeah, so those are all things that basically also have an effect on how, in terms of the energy performance a city, works. In terms of the education, what we also found in the studies, in the literature, was that the higher the level of education is, the more awareness people have about the energy consumption, and the more they are prone to lower their energy consumption there, right? And then, of course, as we were talking about first, it's about the soft properties. It is about the perception. I mentioned before the example of the indoor climate, like how people feel when they're indoors. Is it too warm? Is it too cold? And how is this reflected in the settings of a heating system, right? Also about the usage of the public space, like which has a very big impact on the economic performance of a city, but also about the mobility patterns within a city. At the same time, now, also when we talk about behavior change, like how can we basically support people in order to change their behavior for energy consumption, it is about to whom do we talk to, yeah? Like what are the people and what kinds of incentives that we need to have in order to support this, yeah? There's also like one model that we include in the biped digital twin on that. Overall, I can say the more insights that we have on the complexities of a city, and hence also the more data we have on that, that reflect those insights, the more holistic a digital twin can be. And this is what we are doing in biped. Yeah? So we are the first digital twin that is discussing a pad development that includes data other than the energy topics and the mobility topics. And this is where we work really, really hard. And right now we are in the middle of it, and things are looking pretty good. And yeah.
Well, thank you for this extended answer, Martin, and for all very insightful responses. I can certainly say I learned a lot from you today, and my knowledge of soft data, of cross-sectoral modeling of pets for sure has improved. And I hope that our listeners learn something new and interesting today from this podcast. We'll be having more conversations about pets, about clean urban energy transition in the future. So do stay tuned and see you on the next one.